Salutations! I am Mr. Sullivan, this terrified looking man right here. We also have Mr. Bean, Mr. Bruss, both at Ramstein, and of course everyone knows the man who needs no introduction, the pride of upstate New York, Doug's brother, Mr. Kelly. We will be working with you all year and maybe in years to come all about flip math mastery learning, alright? So today, the very first topic we're going to get into is evaluating expressions and the order of operations. Now, this may be something you know. It may be new to you. Either way, you need to go through this, take some notes, stop the video when you need to, and ask questions. Write questions down. What can you do later on to learn? So, a brief introduction, then we'll get right into it.
This is the moment we've all been waiting for the thousands in attendance and the millions watching around the world. Ladies and gentlemen, let's get ready to rumble!
Awesome. I always kind of need my own introduction because, just pretty special. So, what I want you to do right now is to pause the video. That's right, pause the video, take down these notes. I think it's important that you pause the video instead of trying to copy the notes and listen to me explain at the same time. Some of you can do it, but here's what you're going to find. Because it's a video and I know you can pause and rewind, I'm going to talk a little bit faster than if this was just a class. All right? Because you can pause this. So you need to pause it right now, take the notes, and then continue on and listen to what I'm talking about. All right? Great, so most of you paused it. I can tell there's always going to be some of you who think you can copy and just go ahead and that's what you do. That's fine. Just want you to be successful. So let's talk some math. So a variable is a letter used to represent one or more numbers. The numbers are the values of the variables. And we usually use these as letters. X is a big one. Y we use it a lot as well. These are probably the two most popular, but they can be any letter really. A, B, C. There are some obviously that we're going to try to avoid. I don't like to use I. I don't like to use L. I don't like to use O. These both look like the number 1. This looks like the letter, the number 0. And I don't want you to get confused. I will try to avoid them. I probably avoid J as well. But you can use them. Now you need to understand that if we have a situation where A is 2 in one problem, A is not always going to be 2. It may be 2 this time, and then next time it could be 7. All right, it's going to change. It is going to vary. That's why it's called a variable, all right? An algebraic expression is also known as a variable expression, and it's an expression that includes at least one variable. So we could have a number and a variable, and that right there is a variable expression. We could have 2 plus y. That is a variable expression because it includes at least one variable. So I would again pause the video, copy this definition down, and then unpause it and get right to it. So here we go. It says evaluate. Evaluate, it means to substitute a number for each variable and perform the operation or operations and simplify the result. All right, so this is kind of like the directions. It tells you what you should be doing. Now, I often refer to this as plug and chug. I'm going to plug in a number for a variable, and then I'm going to chug and do all the work and spit out an answer. All right, so the first one here I have n is 3. So when I come down here, instead of n, I'm going to put 3. So 3 minus 2, and I know that 3 minus 2 is 1. This is the substitution part. This is the simplifying part. Do I have to simplify, Mr. Sullivan, all the way? Of course you do. If I have a fraction like 4 over 6, do I have to simplify it all the way? Of course you do. That's part of evaluating, all right? Over here, we have 5n plus 2. Now, this one's kind of tricky. You don't see any operation here. I definitely see a plus 2. I see a 5. When I don't see an operation, plus, minus, I know that I can write times like this. I can write divide like that. I'll tell you this. When I see a number and a letter right next to each other, There's no operation there. It doesn't look like anything. It is always multiply. And we can use parentheses for multiply. Now, we're going to learn later in the video how to solve this using our order of operations. I can tell you right now, I'm going to multiply first. 5 times 3 is 15, plus 2 is 17. That is evaluating. I plugged it in, and I simplified the result all the way down. All right, so now we have powers, and a power is an expression that represents repeated multiplication of the same factor. These are also known as exponents, all right? Exponents or powers. And so we have here 5 to the third power. This is the power. This is what we call the base, all right? The base is the number we repeatedly multiply. I'm not multiplying 5 times 3. I'm multiplying 5 this many times. 1, 2, 3 times. So 5 times 5 is 25. Multiply that by 5 and I get 125. So I have 3 factors of 5. All right? When I come down here, I want to write the power in words and as a product. Remember, if I'm going too fast, what could you do? Pause the video, go back, rewind, see what you missed. All right? So write the power in words and as a product. So we have 8 to the third power. So 8 to the third power. And as a product, product is multiplication. So I'm going to write that 3 times. 1, 2, 3. All right? Some people would know this. When we have a third power, it's called cubed. So you may write 8 cubed. All right? Over here we have x to the second power. X to the second power. So I can rewrite that as x times x because I have the factor or base x this many times. And when we have it to a power of 2, sometimes we call that squared. So you could have written x squared. So you want to, before you move on the video, you want to make sure you have everything on this page. If you don't, pause. Make sure you get everything before you move on. All right, so now we're going to talk about the order of operations. The order of operations, in other words, what determines what goes first and in what order. Do I multiply? Do I add? Do I subtract? Do I take a square root? What do I do first? We all have to have the same order of operations so that kids in Baumholder do it the same way as the kids in Ramstein and Kaiserslautern, all right? And kids all over the world are doing it this way. So we have a mnemonic device. It's GEMDAS, all right? Some of you may have heard it as PEMDAS before. I'll explain why I like GEMDAS a little bit better. But right now you just need to know that, yes, it is also Mr. Kelly's, it's like his pseudonym, all right? That's what he goes around, and he dresses up and as a wizard, and he calls himself GEMDAS. Like he went to the Wondering World of Harry Potter, and this is him walking around, and he introduced himself as GEMDAS. It's a little weird, but, hey, Mr. Kelly's Mr. Kelly. So the first one is grouping symbols, all right? What are grouping symbols? Grouping symbols are anything that keeps stuff together. I have parentheses, and I could group a bunch of stuff in here with parentheses. But it's not the only one, and that's why I don't call it PEMDAS. A lot of people call this PEMDAS, and they say parentheses instead of grouping symbols. I want you to think of things that group other things together. And parentheses can be used more than just grouping. They can be used for multiplication. What else is a grouping symbol? Sometimes we use brackets. A fraction bar will group the top and separate it from the bottom. A radical is a grouping symbol. An absolute value bar groups stuff inside there and keeps it away from the stuff on the outside. So those are all grouping symbols, and that's where you would go first. The next thing we have are exponents. All right, exponents, those are our powers, and we just learned about those. So that's the next thing we would do. The third thing is tricky. It's multiply or divide, and it's in left to right. So in other words, if I have 10 divided by 2 plus 4, I know that GEMDAS multiply comes before division, but 10 divided by 2, this is left to right. So I'm going to do, times here. I'm going to do 10 divided by 2 is 5. 5 times 4 is 20. See, if I did it the other way around, 10 divided by 2 times 4, if I did multiplication first, 10 divided by 2 times 4 is 8, and 10 divided by 8 is not 20. All right? This is why it's always left to right. The same with addition and subtraction. It is always based left to right. Now, with addition and subtraction, you won't get yourself caught in as many traps, especially if you realize that minus 2, if I do 4 minus 2, that's the same thing as 4 plus negative 2. If you understand that, you're going to be okay. So that won't get you into as much trouble as other things. But this is GEMDAS, not PEMDAS. Let's try a few here. We're going to simplify these. So I'm going to write GEMDAS. I have multiplying right here. I have a power, don't I? That's exponent. I have division. That's a fraction bar. But it also is grouping. It groups the top. So I have to start with the grouping. So I have to start on the top. What do I have on the top? I have multiply or exponent. We'll have to do the exponent first. So I'm going to do 3 times 25 plus 5 squared. 5 times 5 is 25. All right. Still have grouping on the top. Now I have multiply or add. Multiply becomes before add. So now I have 3 times 25 is 75 plus 25. Still have grouping on top. So I have to do 75 plus 25 is 100. And now that grouping turns into a fraction bar, which is division. Divide, 100 divided by 50 is 2. All right? Now, there are always some shortcuts you can take. I totally get it. I could have gone and done 3 times 25 at the same time I did 5 squared. It's just tricky. I tend to write everything out. If you go from here to here, that's not okay with any of us. You need to show us your work, whatever work that is. And it cannot be, I plugged it into the calculator. All right? That does not work. Write down your steps. If you need to plug in 3 times 25 to get 75 in your calculator, it's not a great thing, but you have to do that. That's fine. I don't mind you using a calculator, but I need you to write your work down. All right, down here, let's do GEMDAS. We have grouping. We have grouping again. We have some subtraction. We have some exponents. We got a bunch of stuff going on here, and then we have some mystery one out here. Let's see what we got here. So first thing I know I have to do grouping. So I look in here, and I'm just looking at this. I'm not even looking at the 8. In there I have grouping as well. So I have to do that first. So I'm going to do 8 brackets 20 minus, now 9 minus 5 is 4. 4 squared. I still have to do that. Now inside this bracket I have subtraction and exponents. Exponents comes before subtraction, so I have to do that. So 20 minus, what is 4 to the second power? 4 times 4 is 16. And I still have grouping, so I need to do that. 20 minus 16 is 4. Now, this is that magical one. There's really no operation listed, right? I don't see a plus. I don't see a fraction bar to divide. I don't see a division sign. I don't see a minus. I don't see any of these things. When you don't see one, it's usually going to be multiplication. This is 8 times 4, which is 32. There you have it. All right, let's evaluate. So we're going to combine the two. We're going to simplify after we plug in. So this is 6 times what is y? I'm going to plug in 11 squared minus 13. So now I have GEMDAS. I have subtraction. I have an exponent, and I have multiply. So my exponent comes first. So 11 squared is 11 times 11. That's 121 minus 13. Between multiply and subtract, I need to multiply first. 6 times 121, that is 726 minus 13. And again, if you don't know that off the top of your head, you can use a calculator. That's a good idea, but you can still write the step down. All right? Don't go from here to here. Go from one step to the next. And then last but not least, 726 minus 13 is 13. And there you have simplified. Look at this one when b is 3. So 3 because I have b to the third minus 21 over 5 times 3. Remember, a letter times a number and a variable, that's times, plus 9 equals. So now I have this grouping symbol right here. So now this is one of these shortcuts that I don't mind you doing. I'm gonna simplify the top and the bottom in the same step. So on the top I have power and subtract exponent comes first. 3 to the third, that's 3 times 3 is 9 times 3 is 27 minus 21. On the bottom I have multiply and add. I need to multiply first. 5 times 3 is 15 plus 9. Still grouping, so I'm still going to do the top and the bottom. 27 minus 21 is 6. 15 plus 9 is 24. And our last step, divide, which in this case, if you divide that, you would get 0.25, or you could simplify it. 6 goes into 24 4 times, 1 over 4. Okay? In general, do I want a fraction or a decimal? If it doesn't state it, usually we don't care if we start with a fraction, end with a fraction. If we start with a decimal, end with a decimal. If we don't start with either, you can end with either. We understand that, all right? So now what I want you to do is I want you to pause the video and try these two all on your own, all right? Don't do them with me. Do them on your own. Check your answers, see how you did, and then determine if you need more help. All right, so pause the video. So this first one, we had grouping, exponents, and adding. I did the grouping first. 1 plus 5 is 6. Then I squared it, got 36 plus 5 was 41. Down here, the very first step I did was I plugged in my values. So H was 4, K was 2. I had my subtraction, I had grouping. So I did the grouping first. 2 minus 2 was 0. Then I had 2 times 0, because multiply becomes before subtraction. 2 minus 0 was 0, and then 4 minus 0 is 4. So now you're going to do some practice and some applications. Please check your practice answers. Don't copy them. They're online. You can check them. Some of us have notebooks in our rooms where you can check the answers. Check your work, see what mistakes you make, and learn from it. We're not so big into just what you do. We're big into what you learn and show us you've learned. When you think you're ready, then you're going to take your first mastery check, and I wish you all the best of luck, and I will see you on the flip side.